I'm the Deputy Director of our UNESCO Center and heading the data actions. So we have 3 data centers, and Philipp Saile was mostly engaged in this exercise here. He's responsible for our GEMS Water Data Center, which we do operate on behalf of the UN Environmental Programme. So what you see here, it's a global map of water quality data member states deliver for us. Main purpose for GEMS studies and for the GEMS data center is to report to the SDG process. In detail, we are responsible, and we also have developed, not alone, but with the community, also the SDG indicator 632, which is a one for the ambient water quality. And that's the main result here. We have also published for the research community another data set which you find on Zenodo. Here we have a DOI. Otherwise, I mean, that is a typical for operational data centers. We do not provide DOIs because the time series are regularly updated on different times. That whenever member states deliver data, that might be on near real-time observations, that might be on reporting issues, whatever. That's really diverse. Therefore, the original data set do not provide a DOI. Next slide, please. So exercise was then to bring a subset of that first for testing to the to IHP-WINS. It's what you find is also under the link of the featured data set so far, but honestly it's not yet the full data set which GEMS data center is providing. But that one which is in Zenodo, which is kind of a subset, open data only, because we have also, of course, data from the member states which are not allowed to be shared openly, but that are the ones which we can deliver. And we added it to the IHP-WINS also by enriching it with additional metadata, which was not so far connected in the WINS system. Next slide, please. So this is how it might look like, just to show one example. So as you see at first glance, we have to do some fine-tuning. On the other hand, I mean, first congratulations also to the WINS system. I mean, we're looking for the first attempts quite a years ago until what is approved now, also with a new platform based on CCAN and the data view. That is a really major step forward into the really right direction, which is great. With on-the-fly visualization and so on. But working with the big global data sets, we also faced some issues, which I want to highlight a little bit here, so something where we have to work together on that. So first, the data has been transformed to include coordinates. I think maybe that can be overcome using APIs, which would we also favor, honestly. But as always in data, or not always, but mostly in databases, in the database, I mean, we have separate tables for station metadata and the time series objects. If you want to upload that as a CSV file, which we have done here and which we have been requested to do though at that time, then we have to combine that files, different information into one file, which was extra effort for us. But as I said, with API, that can be overcome. For the viewer, we have data gaps, and that is why we selected these examples here. And in the original viewer, it seems that we have this linear interpolation, which we have to check why that is the case and what is the reason for that. So we have to work on that one. And lastly, the on-the-fly visualization is time-consuming. And it's really resource intensive, and the user experience might be hindered if not enough resources are there. That are our observations. I don't know, maybe we can discuss if you have had similar experience maybe. Next slide, please. So lessons learned, it's really well suited, it's a really good development. With the API, we could maybe provide a better user experience, so that will be our next thing, what we want to do. A general idea is, concept is, and that is, I mean, also the topic of this presentation here, we aim to should aim to go for a standardized data model and encoding, no? And that is important for the integration of different data sets. I mean, colleague Park from Korea might give you a really good insight how they have done that and what vocabularies they have used. We are quite active also in the WMO, of course, and Philipp is also heading the data, the task team on bringing hydrological data into the WMO data exchange system. So controlled vocabularies, metadata standards play, of course, a big role here. So we're quite advanced here, but I think we should also use the IHP community to share that information as well. Last slide, I think, and that is the who's, maybe hands up, who have seen that slide in before? Saile, you don't have to. No, it's only one. But I mean, that is, I mean, two people. I mean, that is maybe also interesting for you. So WMO is that UN specialized organization who's there for data exchange, let's say, no? And the WHO's is not, and there for operational hydrology. But on the other hand, they're developing right now with the WHO's, which stands for the WMO Hydrological Observing System, and data discovery and access broker system. So also an exchange way compliant to your APIs which you might in the system. And our suggestion would be also to link that to WINS. Philipp Saile is already working on that. Some of our data centers and are compliant already to the WHO's. Also Elizabeth's ICREC, for instance, is partnering, of course, here. And we see here a big chance also to reduce resources, working on, let's say, that as a common standard and develop that as a common standard and develop that together further. I think I have a last slide, but we can, yeah, that is, let's say, the recommendation. Click. Yeah. Maybe another last thing for me, maybe also looking at the research communities and recommendations. I mean, collaboration is key. And in all that data exchange business, there are huge scientific communities working on. Starting, I mean, in Germany, we have the NFD4E, stands for the National Foundation for Research Data Infrastructure. We have in EU, I mean, that is now the, let's say, European view, but there are in other continents similar approaches. From the European Geophysical Union, we have this Earth and Space Science Informatics sessions, and I don't know how many people, colleagues are working on that. I would say it's at least in the hundreds, maybe thousands of scientists working alone in that group. And then we have to make that more global also. We have the data committee of the International Science Council Union, and all that they are quite engaged in that one. And I think the role, of course, we have WMO OJC on the operational field, but I think the link to IHP would be also a recommendation, really, that we should reach out to that data-centric research communities which are existing, because they're doing a great job, and I think we can learn a lot from them. And with us, hydrology data, they have the use cases which are relevant. Thank you.